All right, so we're going to take a look at section 4.5. We're going to look at it in 2 days. And first thing I think I'm going to show you is just a diagram, which you already have on your notes. But the idea here is these 4 points, they're a scatter plot. Okay? And whoever made this scatter plot tried to draw in a line, and they drew it in so it went right through 2 of them. You got one below, one above, 1 point below. Well, there's a difference between the point that was on the scatter plot and then kind of like this point right here that's on the line. Does everyone see how the line doesn't go exactly through the data point? It's off by, how many is it off by?
3.
It's off by 3, okay? And the data point is 3 units above the line, okay? So since that point is above that line, above we think of as positive. Okay, this other point, where is this other point? It's below. Okay, when you think below, it's called a negative. Okay? And the residual is how far away it is from the line. So right here, there's a residual of positive 3. It's 3 units above the line. This is 2 units below the line. So this would be a residual of negative 2. Right? And what we'll do is we're going to keep track of how far points are off. Okay? And that kind of tells us if this line is a good fit or if it's not a good fit. So if the line is a good fit, do you think you should have a big residual number or should it be small? What do you think? The residual is how far away the point is from your line. Small, right? If it's big, that means the point is really far away from the line. You don't want that. This line should be as close to the points as you can get it. Okay? So we're hoping for small residuals. Okay, so on your notes, I think you've you got a couple blanks on there with the words in bold. And it says that a residual is the difference between, and I'll kind of circle it as we do it, the y value of a data point and the corresponding y value if you go straight down on the line of fit. Okay,
Guys, that might seem a little bit, the way it's worded may seem a little bit confusing to you, but once we show you how we're going to figure out how to get your residuals, then it won't seem as bad.
Okay, so the goal, hopefully, is when you find a residual that it's a small number, very small, like 1 or negative 1. That means that it's only 1 unit away from where it should be. If it's big like that, like a 3, that means that this line is 3 units away from where it should be. So there's 3 different cases for a residual. If the data point is above the line, that's positive residual. If the data point is below the line, that's a negative residual. How could you get a residual that's 0? Where would the data point have to be?
On the line.
Yeah, it would end up right on the line. So if I change the scatter plot a little bit, in red, that's an original data point. That's an original data point. Let me add one more right here. That point that I just added would have a residual of 0. Because if you measure how far away this point is from the line, it's right on it. Okay? How about if I put a point right here? How far away from the line is that point? It's positive 1. So that point has a residual of plus 1. How about if I put a point right here? That's a residual of negative 1. It's 1 unit away, but it's below. So that's all you're really doing is counting. How far away is a point from a line? Or if it's right on it, it's 0. Good. Does anyone else need to copy those 2? No? Okay. So for a lot of the problems we're going to look at, we're going to make this table. We're going to have 4 columns, and we're always going to put them in that order. We're going to have x values, y values. This next column says y value from model, and the last column says residual. So first of all, these 2 columns are going to be given to you. Okay? They're going to come from data that's in the problem.
So guys, you have a bullet, you have that chart, obviously not filled in, but you have that on your notes. You just want to fill in the first bullet right now. The X and Y columns come from the data given in the problem. So you have the bullets, just fill in the information.
Okay, and I'm gonna come right back to this, but just to kind of show you an example. Here's an example you're gonna have. The X and the Y column is already filled in for you, okay? Because they're gonna give us that in the problem. And this, when we get to it, this is actually something we did yesterday. You guys remember the DVD sales problem? Yeah, I know, you weren't here, Jody. Actually, nobody was here, you're right. On Monday? You guys remember that one, the one with the DVD sales? This is the DVD sales problem again. It's the exact same table. So these are your X's, those are your Y's. Okay, so just fill those into your table. Okay, the next thing, one of 2 things. They're either going to give you a model, okay, or you're going to have to find it yourself.
I think in most cases, guys, we're going to give you the model. We're going to give you the equation.
Yeah, unless it's like from yesterday's lesson.
Yeah.
Okay, so from yesterday's lesson and in the homework, you guys found the model yourself. Okay. Today, to kind of speed that part up, yeah, we'll probably give you the model. Okay. So the way that you fill out this column is you're basically going to plug in an X value into the model. You're going to plug in an X value into the line of fit equation. Where do you get this X value from? It's going to be given in the problem.
This, you set up charts, maybe not exactly like this before, but when we did graphing and things like that, we've done things sort of like this, guys. We took the Y, we took the X value, had to plug it in to give you Y. We're doing a similar thing here. We're taking the X's that are given to us, find out where X is in that equation, or that model, and plug it in.
And this is a step. You're going to have to do it sometimes 6 or 7 times. Okay, you're going to have a bunch of numbers you have to plug in for X. You got to do each one at a time. Right, so I'll come. Yep.
Sometimes those X values are small, like 1, 2, 3, 4. Sometimes they might get a little bit bigger depending on what we're talking about.
Yeah, they could be anything. Yeah. So I'll come right back to this. I just want to show you guys in the problem where the X values are and where you're going to plug them in. Okay. There's an X value. Okay. In this problem, X is going to represent the week. You're going to take that 1 and you're going to plug it in for X. Okay? You're going to get the answer, and you're going to put it right there. Then you're going to take the 2. You're going to take and plug that in for X. And then once you get the answer, you're going to put it right there. And you're going to do that for numbers 1 through 8. You're going to plug each one of those numbers in, one at a time, for X. Okay, that's probably the longest part. Okay, doing that calculation. Okay, the third column. Okay, how do you get the residual? Well, if you've got a picture like we had at the beginning, you could just look at the picture and count. But sometimes you might not have a picture. In this problem, you're not going to have a picture. Okay, so if they don't ask me to make the picture, why would I bother? It's going to take extra time. So this is the formula to find the residual. This is column 1, 2, 3, 4. Subtract the y value minus the y value from the model. Column 2 minus column 3. You do that for each value. And you're going to put the answer in that column. Any questions on that one? Just take what's in column 3, column 2 minus column 3, put it right there. Okay, now the last thing we're going to do is we're going to make a picture of the residuals. Okay? A little different than what we did yesterday. This is not really like a scatter plot. Okay, it's a picture of residuals. And what that's going to tell us is how good a line of fit we have. Okay, so when you make a picture of the residuals, you only need 2 of the columns. You need column 1 and column 4. Okay, so the last step, if they ask you to make a picture of the residuals, which they won't always do, but sometimes they do, you're going to make a plot, and the plot is going to be using the x values, which is column 1, and the residuals, which is column 4.
Guys, what does Mr. Hager mean by that? The points on the plot are in the form of X residual. How can you, what does that mean? Anybody want to tell me? What's that mean? What does he mean by that? When it says X residual. He said do a plot or whatever. He's asking you to graph the residuals, right? So what does that mean? Think how you graph a coordinate, x, y, right? He's saying that your coordinate now, how to do it is going to be, first thing you graph will be the x, and then the residual. Those are like that's like your point right there, x residual. That's how you graph it. That's what he means by that.
And I think we have 2 problems, so what we'll do one together, and then we'll let you guys try one. And is there anything else that, so this is just getting at what we said earlier. Okay, this, you could just read this, you don't have to write this.
Yeah.
But it says, if your model is a good fit, okay, if it's a good line, then the residuals are small, okay? That's what the goal is. You want small residuals. That means the points are pretty close to where they should be. Okay? If you get residuals that are big, your line is not a good fit, okay? And just like when you put in a line of fit, we try to space it out so we have the same number of points above and below the line. Well, when we draw our residuals, we should pretty much have the same amount of points above and below the x-axis. That's what I mean by evenly dispersed. Okay? If every single point was above the x-axis, that wouldn't be a good fit. That means we had all positive residuals. We didn't have any negative. Okay, you should have a balance of positive residuals and negative residuals. They should balance.
Yeah, it's almost gonna make like a nice pattern. When you see it, if it's a good fit, then it'll be like a pattern when you graph your residuals.
All right. So let's do this one together, and then you guys can try example 2. All right, so this problem says in section 4.4, I think it was the last problem we did, this was the equation we came up with as a model for our data. Okay, you guys figured this out, you came up with it. Each week here is is the week that a DVD has been out. And what do you notice about the DVD sales the longer the DVD's been out? Yeah, it goes down. And you guys yesterday said that that was a negative correlation, which was good. All right, so now what we want to do is figure out the y value from our model. Okay, the model isn't going to be perfect, but the number here and the number here should be close. Okay, hopefully it's not off too much. So let's start with 1. Let's plug 1 in for x. Derek, if I plug 1 in for x, what's negative 2 times 1? Yep. And now you've got negative 2 plus 20, which is the same as 20 take away 2, 18. Now, did my model give me a pretty close prediction to what it should be? What do we think? Did the model give me a pretty close prediction? Yeah. The model gave me 18. The actual value is 19. Okay, that's not off that bad. It's only off by 1. That's okay. Now let's plug in 2. Ashley, what's negative 2 times 2?
4. Negative 4.
And what's negative 4 plus 20?
It's negative.
No?
No. 6.
16, right? Negative 4 plus 20 is 16. Again, I'm going to ask the question, did the model give me a pretty close number to what I should have actually gotten? Yeah, it's close. All right, how about Antonio, what's negative 2 times, what's the next number I'm going to plug in for x? 3? What's negative 2 times 3? Negative 6. I can write that down if we want. And then I have negative 6 plus 20.
I'm 30.
14.
14. Is that close to what I should have gotten? So far, the model is giving me values that are pretty close. It's a pretty good model. Next x value I plug in is what? Plug in 4. Negative 2 times 4, Vanessa.
Negative 8.
So negative 8. And then we're going to add 20.
12.
We get 12. Again, the model's giving me a value that's pretty close. So far, the model hasn't given me anything exactly right yet, but it's close. How about Sabrina? Next x value? 5. What's negative 2 times 5? Negative 10. And we got to add 20. What? 10. How close is the model this time to what I should have gotten?
On the dot.
It's right perfect, okay? That's going to be a 0 residual. That point is perfect. It's right exactly what it should be. Let's do 8. What's negative 2 times, 6. What's negative 2 times 6? Yeah,
Negative 2 times 6 is
negative 12. And Hannah, what's negative 12 plus 20? That would be negative 14 plus 20.
8.
8. How good of a prediction did the model give me this time? Perfect. That's going to be another 0 residual. So far, we've only either been off by 1 or it's been perfect. So this is pretty good.
Kind of like you, Mr. Hager.
Yeah, sometimes.
Teacher what?
What's the next x value? 7. Plug it in. What's negative 2 times 7?
14. Negative 14.
Negative 14. We have to add 20. 6. Did the model give me a perfect prediction? No, it's off a little bit. We'll find out how much it's off in a second. And what about the last one? What's my last x value?
It's negative 16 plus 5.
Yeah, plug in 8. Negative 2 times 16. Antonio, what's negative 16 plus 20? 4. Okay, so now we've got all the y values that the model predicts. We've got the actual y values from the problem. We're going to find out how much they're off. What do your notes say to do to find the residual? Column what minus column what? Exactly. That's why we set it up this way. Just put a subtraction sign right there and just do it out. What's 19 minus 18? 1. What's 15 minus 16?
Negative 1.
Negative 1. 13 minus 14. 11 minus 12. 10 minus 10. 0. What's the next residual? 0 again. Next one? 1. And the last one? 1. So what do you think? Is this line a pretty good fit? Yeah. At most, it's only ever off by 1. There's a few points where it's above. There's a few points where it's below. And there's a couple points where it's right on. So now we're gonna make a picture of that model. You guys have this grid on your paper already? Okay. So I asked you, and then Mr. Roy kind of asked a little bit more about it. What are the points we're going to graph here? It's the last bullet. Yep. X, comma, residual. Okay, so let's scroll up. And if I highlight what you guys are looking at, you're graphing X, comma, residual. Okay, what I just highlighted in yellow. So, Emma, what's the first point I'm going to graph? 1, comma, 1 what? 119? No.
1, 1.
Why is it 1? Why is it 1, 1?
You said you have to do X and the residual.
Exactly, what I just highlighted. The X value and the residual. So 1, 1, 1. Okay, so this axis is labeled a little differently. It's going by halves. That's 0.5, negative 0.5. It's a little different, but that's fine. So 1, 1 would be right there. Okay, what's my next point?
2, negative 1.
2, negative 1. 2, negative 1. Perfect. Next point.
3, negative 1.
3, negative 1.
4, negative 1.
4, negative 1. All right.
5, 0.
5, 0. Yep.
0.
6, 0.
7, 1, and 8.
7, 1, and 8, 1. Okay, how many positive residuals do we have? 3. How many negative residuals? 3. Are they balanced? Do we have just as many of each? We just said we had 3 positive, we had 3 negative.
Yes, balance.
Yeah. You might end up with 4 positive and 3 negative. That's still pretty balanced. And we had 2 residuals that were perfect. Okay, 0, right on it. So that's a graph of the residuals. We didn't do that yesterday. So what did the question say? Is the model a good fit? I would say put down yes. It's a good fit because we have the same number of positive and negative residuals. And we even had 2 that were perfect. So it's a good fit because we have the same number of positive and negative residuals. Okay, so when you do one, if you make a graph and all your residuals are like this, in red, that's not good. That means every single residual was positive. That means your line of fit is not good. You should have some positive and some negative, okay? So they might not always be good lines of fit, but this one is. All right, everybody had that? So example 2, Mr. Roy, they get the table already?
Yeah, I got it.
Perfect. Okay, so number 2, try to do what we just did in example 1. Find the y value from the model, find your residual, and then make a graph of the residuals.
Sure, why don't you give these out now? They can use them for this too, you know what I mean?
Yeah. Okay. So take about 5 minutes and see if you can do what we just did again. Okay, so as I walked around, we got the first 3 residuals. Most people were, or first 3 y values. Can somebody give me the next y value from the model?
46.4.
Yep, 46.4. How about the next one? Anybody get the next y value? This one comes out nice. Kaylee?
47.
Yep, 47. How about the next one? Yep, you should get 47.4. Okay. Ashley, how about the next y value?
I didn't get to that one, I have right there.
Right there?
Oh, I got, 48.6.
Perfect, 48.6. And the last one, I think you should get a nice answer without a decimal. 49. Now, what do we do to get the residual? What do you have to do? Subtract that minus that. Okay, what's 42 minus 45? Now, some of these we need the calculator. Did anyone get the next one? Yep. How about 47 minus 46.2?
0.8.
All right, that's good. How about the next one?
3.4.
Okay, good so far. 52 take away 47.
5.
5. How about the next one?
3.1.
Anybody else get 3.1?
I got 3.3.
Yeah, I think it should be 3.6. Just double check 51 minus 47.4. How about 49 minus 48.6? 0.4. And what's 45 minus 49? -4. Good. Before I even graph it, okay, in fact, I'm not even going to graph this one. What do you guys think? Is this a good fit or no?
It's a little wild. Okay. Actually, hold on. No, yes. There'll be 3 positive. No.
Why is this not a good fit? Shannon? All right, so Shannon was telling us why this is not the best fit. How come?
Because there's only 3 negative residuals and then there's 5.
Yeah, the residuals don't balance. You've got 3 negative, 1, 2, 3, 4. You have 5 positive. That's not a good balance. And look at how far off the residuals are. 3.4, 3.6, 4. That's kind of far off. Like you really should be getting 1s, negative 1s, maybe a 2. But these are too far off. Okay? So this one I would say no, not a good fit. All right, so let's just put down no, not a good fit because let's just say we have, yeah, we have more positive residuals than negatives. It didn't balance out. We had more positive residuals than negatives. So this line is not a good fit. Any questions on that table? Okay, I didn't graph the residuals this time, but that's okay. If I was going to graph it, what 2 columns do I use? Shannon? The X column, comma, comma, the residual. That would be what you'd graph if we were going to graph. And we put that little symbol in there because we skipped a bunch of numbers between 0 and 30. All right, so the last thing I'm going to show you, and probably the most important thing, right, is what's on the back. Okay, you've got directions for how to do this, but I think the most helpful thing is really just to watch me do it, okay, and try it as I'm doing it. So when we've been putting a line of fit, all we've been kind of doing is guessing, right? We have a bunch of points,
Yep.
and we just try to guess at what we think the best line is. Well, there's a way to actually find the perfect line. Like it is the most perfect line you could possibly
That
have
information.
with that information. Okay, and that's what that calculator can do for you. So all I'm going to do is show you how that calculator can give you the slope and the y-intercept of the most perfect line for that information. Okay, and it's not that hard. You just got to type some stuff in, and then it'll give us the information we want. Okay, so what we're finding now is called not just a line of fit, but it's a line of best fit. It's the best line you could possibly have. We're not guessing. It's perfect. How the calculator is giving us that line, don't worry about that. All you have to know is the calculator can do it.
And guys, we had to do this on a test or something. We'd have the steps. We'd probably put the steps on like the reference sheet or something for you guys. You wouldn't have to memorize. So this, just follow along step by step. We have you in your notes. Don't worry about memorizing it. All right, again, it's not, we just want to show you guys another way to do this, that's all.
Okay, so what I'm going to do is I'll do the problem as we read the directions, so you can see the steps and you try it as well. All right, first thing, I just want to make sure everybody is at that screen.
And we have a blank screen.
Is everybody's calculator on? Okay. If you have stuff on the screen, you can just press clear. Okay. All right, so what's the first thing that step 1 says to do? Press stat. Okay. Stat is the button that's right below delete. Okay, it's right near the arrow. Does everybody see stat?
Yes.
Press it.
Okay.
When you press it, you should see this screen. Is there anybody that doesn't see this screen? Okay, what does it say to do after you press stat? It says go to edit. Is edit already highlighted on my calculator? Yes. So all you should have to do right now, if yours is your number 1 highlighted?
Yeah.
Is there anybody's number 1 that's not highlighted?
Everybody's good?
Press enter.
Press enter there.
Yep. Okay, is there anybody that's not at this screen? You should have L1, L2.
I have an L3.
Yep, you have an L3 after it. All right. Okay, so now you should see that screen. Next step, we're going to type in these X values right here. I want to type in those 1, 2, 3, 4, 5, 6, 7, 8 numbers into L1. Okay, so I'm going to show you how you do it. On your calculator, does everybody have a black box that's in L1 right now? Yep. If you have anything else that's in that box, like let's say somebody was using the calculator before you and they left the number 8, just click on it, press delete. So you shouldn't have anything in L1. It's everybody's L1 blank. Okay. Now, the first number I want you to type in is 2.0. So type 2.0, and all you have to do now is press enter. Okay, it might just change to a 2. Does everybody have a 2?
Yes.
Right there. Okay. Now type in 3.7. And hit enter. Okay. Does everybody have a 3.7 below the 2? Okay, keep going until you type them all in. 4.2, 1.9,
Under L1, you're putting all those values. And you can't see on the board, you also have it on your notes. You have that same exact chart. So all those that Mr. Hager circled in blue, all the X's, are going at L1.
Okay, what's going to happen is you type them in, the top ones are going to go off the screen, but they're still there. Okay, it's just they're off the screen. Okay. Anybody that needs help typing in those X's? Okay. Next thing we have to do is type in the Y's. What list? That's L1, that's the first list. Where do you think I'm going to put the Y's? Yeah, I want to press the right arrow. When you press the right arrow, okay, that box should go over to L2. What's the first Y value I type in?
60.
60. Hit enter. What's the next one? 83. Okay, and keep going till you type all those in. 72. If you make a mistake, you can just highlight the number like I did. Just type in a new one if you enter it wrong. What's the last one? 85. Now, when you're done, L1 and L2 should have the same amount of numbers in it. If you have something like this, it's not going to work. I have an extra number here that I don't have here. Okay? Was everybody able to get their numbers in L2? Any questions on that?
Everybody's good? Speak now, for hold your peace.
Okay, so now we've put all our data into the calculator. Okay. Last thing we need to do is tell the calculator what to do with all this stuff. Okay, so after you type in all your data, okay, everybody press stat.
Yeah, let's say Mr. Hager's is kind of like that, right?
Does everybody have that on the screen? Press stat, and then it says press the right arrow to go over to calc. So if you
Can I have your attention, please, for a couple of announcements?
Not calculator.
I'm so excited.
all right, so everyone's at this screen? Press stat.
So, Mr. Hager,
All right, once we get to this screen, what does it say the next step?
on all their things, it's hit stat again to get there?
Yeah,
So guys, on that thing, hit stat. Right here.
press stat.
Yeah.
Okay, next thing, press
Everybody
the,
going there? Everybody's there?
press the right arrow.
Stat, 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 stat.
Now, once you press the right arrow, what's highlighted on your calculator?
Press one.
Calc. Is anybody's not highlighted that says CALC? That should be highlighted.
Calc. Mark, calc, and Becky.
Who is that?
Now, next thing, after calc is highlighted, we have a bunch of options. On the directions, which one does it say to pick? Yeah, it says Lin Reg. So if you hit the down arrow,
Lynn Ring.
on my calculator, it's the fourth option. Did everybody get the fourth option
Lynn
highlighted?
Ring. Oh my God. So you're on Lynn Ring? Yes.
Okay, what does it say to do after we highlight that? Hit enter. Does everybody have that on the screen?
Yes.
I woke you up.
What does it say to do now? Hit enter again.
There it is, Lynn Ring.
How many people got that? Good.
I did the 10.
One of those numbers is the slope. One of them is the y-intercept of the perfect line. Which one do you think is the y-intercept? The B, 35.1. Put that at the end. Which number there do you think is the slope? Yeah, the calculator calls it A, and if we round it off, what is that slope pretty close to? Let's call it 12. So what you guys just found, that's all you have to write. That is the line of best fit. Okay, it's the most perfect line that goes through the data.
Listen to me, guys. On the homework, once you get it, turn it over to the back side before you put it away. Turn it over to the back side before you put it away. All right? Under where it has the,
Okay, guys, while Mr. Roy's passing that out, just 2 reminders. If there's no school tomorrow, no test. If there is school, test. That's
guys,
it.
3 and 4. You don't need to cross them out. We'll just do them in class on Fridays. You need a graphing calculator, don't cross them out. You do not have to do them for homework. We'll do them on Monday. On Friday. You can't do them because you don't have a graphing calculator.